Hello everyone. In this video, let's find what is the voltage V naught in the circuit. Okay. So to find this V naught, first we need to find whether this is a op-amp is in closed loop or not. And closed loop or this is a closed loop, and we need to find whether this is a negative feedback system or positive feedback system or not. Okay, so in our previous video, we found how to find whether this is a negative feedback or positive feedback system by injecting some disturbance at output node. In the same way, let's to recall that one, let's find how to do it. Okay, so if I increase this node voltage here, and this system what it will do, it will sense this output voltage and it will respond to that change in the output voltage, and it is tries to correct this, our system will try to respond to this output voltage. Okay, in negative feedback system, that is stable system, what it will do, it tries to maintain in this negative feedback system, because virtual short will occur at positive non-inverting terminal and inverting terminal. That means this is V in, so this will become V in, and V out should always become V in. Okay, so let's assume there is some disturbance here. So if this is a negative feedback system, what it will do, that means if there is a disturbance which is increasing the V output voltage beyond V in first iteration, this system should decrease that disturbance. That means it should act opposite to the disturbance. We need to see whether that is happening or not in this system. Okay, so let's assume there is a small disturbance delta V naught occurred at output. Okay, if delta V naught error occurred, that means disturbance occurred at this node, then what will happen, this is a Vg, this is Vd. Okay, so what will happen, so Vg equal to, that means proportional to uh, V plus minus V minus. Okay, Vg is proportional to V plus is V in, V minus is, let's assume I am taking only the disturbance. Okay, so let's assume I am taking only disturbance, so it will also change. Okay, there is some delta V naught, that means this increased from V naught, so it increased to delta V naught. So if, because this whole term, okay, this whole term increased, what happened, this whole term increase, so that Vg will reduce. That means what's happening is Vg is reducing. If Vg is reducing, what will happen to this node voltage, this node voltage is always proportional to the current flowing through this resistor, that means I into this R load. Okay, that will be this node voltage, this, that is V out. Okay, let's find what is the current flowing through this resistor, and we need to know that this MOSFET is in saturation, which is in saturation and not in linear region. Let's assume like that, then let's proceed it. Okay, so for saturation of NMOS, IDS is proportional to VGS minus VTH whole square, because let's assume we decreased VG. Okay, so our VG got reduced. That means, so if Vg got reduced, that means this term got reduced because of Vgs, totally Vgs will reduce, that because of that one IDS will reduce. So what happened, we increased some because of some disturbance, we not increased, Vg reduced, and current, the flowing current Id got reduced, so that V out got reduced. So that means it's acting, the system is responding exactly opposite to disturbance. That means this is a negative feedback system and a stable system. So that what we, in the negative feedback system, what will be this one, let's find. So in negative feedback system, this non-inverting terminal voltage and inverting terminal voltage will be same, and because of that one, this v minus will be V in, and there is no nothing is flowing. That means the current flowing through this terminal equal to 0 ampere because of high input impedance. Because of that one, V out will be V in, and current flowing through the R load will be I load. Okay, I load equal to V in divided by R load. So because of this negative, this is a negative feedback system, this is happening. Okay.